Hi, hi. Can you hear me? Just
We
testing
can
the
hear
mic.
you fine. Brad,
All
could
right,
I have
thank
the
you.
mute button back?
Uh, yes.
Thank you. We can hear you fine. Share your screen and light the fuse. Get on with the show. We see
Okay,
your
can you
screen.
can you see my screen?
Yes, it says SVFIG, Silicon Valley Fourth Interest Group, OmniWeb plus OmniDoc.
Okay, good. Now this is the slide. So I'll be talking about the roles of fourth in blockchain technologies and beyond. Now I have done a few presentation on this, and I think today I'll present it in a different way because I realize what I've done in the past few years is I think I accidentally found a way of implementing database server without the server, just using hash code as the file names in the file system, right? So maybe I'll just repeat what I just said because it's I think terribly important. Uh, Let me just find the slides that I want to show you to explain the idea. Right. So this is on this part. I'm calling it a triple-less card computer. Now, I I suppose this is a very bad English. I couldn't figure out another way of describing it. Basically, it means domainless, kernelless, and databaseless. So today I'll be presenting to you how I actually implement a hash code-based file system without a database, right? Now, if we can achieve this, then we will have something very powerful because, as we all know, Forth is basically a kernelless system, and the domain part is actually from another technology called the Invisible Internet Project. And I suppose many people have not explored this because of, I would say, bad reputation, yeah, associated with the criminal world. But from my own experience, I haven't really explored those criminal worlds just to, make a sort of a disclaimer here. It's actually quite safe to explore this invisible internet project. All right, so I'll just start with my sort of presentation. Now, I sort of switched the order of this introduction and the fundamentals because I think I want to recap some of the basics before I go into the, the more uh, sort of ideal part of this talk. So, okay. Now, this is a name that I sort of come up with after a few years of working on this project. Now, it sounds really simple, but somehow I think us being programmers, we are not so good at making names. So this is called the crypto meta programming. And I'm sure you all know what meta programming means. And of course, crypto simply means that we add another layer of cryptography, especially hash code. All right. Now, if you download my slides, you should be able to sort of click on this and go to the main page. That is how I usually make these slides so that you'll be able to access the page with this link. Now, this is actually from one of the very popular Bitcoin sites. And from here, what I want to explain to you is that the idea of, okay, this first slide here is to show you how forth is actually used in Bitcoin. All right. So here is actually a very simple script. All right. Just to, as you can see, it's said that it just I think it's just a dummy operation here, and you can see the name. All right, so let's start with this signature public key, dupe hash 160. Okay, and equal verify and check sig. Okay, so you have one, two, three, four operations. Now, so this is exactly how we will write a fourth commands, right? I mean reverse police notation, and this is just showing the stacks. So I mean this is just very basic thing for us, but I suppose they are showing this on the website because most other programmers are not familiar with stack machine programming, right? Now, so this page is just to show you the relationship of Bitcoin and forth, all right? Now, the next part, okay, you can also go to this link. I'm sorry, I forgot to put a sort of a frame border on it, but you should be able to click on it. There's a lot of more details on this invisible internet project. Now, the important thing about this invisible internet project is that all programmer will be able to set up our own server without paying domain name system, which eventually will go into uh well, I'm not sure now who is controlling it. I don't know whether it is still associated with the US government or some company now. But anyway, the point is, suppose you need to pay $10 a year just to own one domain name. That is still a huge sort of barrier for a lot of programmers because we like to do testing, let's say with hundreds of thousands of domain. Now with this system, basically, can you imagine if let's say 1,000 or 1 million programmer all set up this invisible internet project, then in combination, the total computing power that I mean, all the free software programmer can command should be bigger than Google, Microsoft, and so on. But the problem is, this invisible internet project was invented in 2003. And unfortunately, somehow no one actually figured out how to use hash code to coordinate. Now, so this point about coordination is something that I'll explain here. How we can use hash code to coordinate between people. Basically, we will say share the computing resources, share digital assets, and so on. So that is the a big part of uh, what I'm going to explain today. Okay, now this slide is actually what I use to, I mean, to explain why we want to do this, right? Now I call this the MAGA, as in Microsoft, Meta, Amazon, Google, Apple, right? I mean, I'm from Malaysia. I don't understand much about politics in US, so I hope I don't offend anyone here. Anyway, I just want to show you that you can see that they are actually the total revenue is 1.8 trillion. Now you can imagine there has been a lot of source code that was taken from the free software programmers. And so in this presentation, I will also show you how we can use hash code to track the usage and rewrite the free software license so that we can actually charge third-party users for using our source code. So that is one of the early motivation of why I'm doing this. Okay. Now this part is the video where you can see we are using the hash of public key as a user ID for login. Now this idea of a hash of public key is actually very important for uh, defining digital assets. All right. And you will see how we do that in the detail. But for now, just to, you know, remind you, this is the concept that we need to remember. You can see the detail in this video. And So basically, all right, this is just a sort of a flow chart of how this public key is being used in doing the authentication. All right, I'll just show it without explanation just to save time. All right. Okay. Now this is the part where I implemented my own fourth, as in this part is actually implemented on top of PHP, but the same architecture or method can be done in almost all other programming languages that that I've tried out, like JavaScript and Java and so on. Now, which makes it very useful for younger programmer to learn forth because they are usually more familiar with what we call the third generation programming languages. Okay, so here I just want to show you there is the loop where I implemented my own forth, which I call for script. So you can see that I actually cut out this whole function into parts. So basically, from you can see that the first part is just to break out the space delimited string and then go through a token, I mean a loop, so to process the token. And you can see here that if there's no function, then we'll push the string onto the stack, all right? And otherwise, we'll just call a function which is user defined. So it's really simple. And I suppose it's not a new idea, but it's just that it's very convenient when I started doing programming in mobile phone and web pages because, as you know, for mobile and web page programming, we got to deal with different environments. So then it makes sense to sort of unify all this. All right. So in the end, I was able to just use one programming language for all the different front end and back end and database and so on. Okay. So that being the sort of fundamentals, so I'll just go through this. Now, as you can see, I list down all these ideas that we may talk about, but obviously we have not much time, so I'll just just go through this very briefly. Okay, so I have explained this before. So as you can see, there's too much money that's been taken away from free software programmer. So we want to find a way to get that back. Okay, and all right. Now, so this part is in detail of how we're going to do the contract part. Okay. So okay, let's go through this on the contract part, how we actually going to start with a hash code. All right. Now, so basically what I have done with this okay, as you can see, this is the all right. Now let me just probably pull it out. Okay, so basically what you're seeing here is actually a web page, right? Okay, that says omnixtar.github.io's contract. And I have implemented the JavaScript. So basically what it does is that you can actually enter a sort of a fourth language like this. And this will create the hash code for hello. So this is just a very simple example. So if I just press enter, and the result are stored on the stack called S. The stack variable is S, so 11. So now when you press S, it just show you the length of I mean the total number of items on the stack. So you just write the last number to get that thing. Now there is actually a very interesting what do you call it property about hash code. All right, that is now if you uh, put the hash code together with another string, all right? Okay, like this. So, I mean, let's say this is somebody else's hash code, right? Okay, and then you put the string, then, and then you take this whole thing together, okay? You take the whole string, and then you can generate another hash, okay? Now, let's try to actually go through this step and see what it actually means. So if you actually open up this page, you can see that there are commands that you can copy and run, okay? And then it will show you how to obtain the hash code. Okay, so I have done it just previously, so I'll just show you. All right, this is the command that I entered. Okay, and so this is the hash code being calculated. Now, this is actually a very important part of what shall we say, digital contract or smart contract. Okay. Now, what it means is that, uh, okay, okay, so this is it. When I calculated the hash, it means that the input string has been fed into a hash function, which means somebody, that means myself, the first party, have already calculated that. Now, if I send this code to you, somebody else, or let's call it the second party, you will repeat the same to verify. Okay. Now, this action done by both party, that means me, myself, doing this hash code, calculating the hash code, and when you use it and then you recalculate the hash code again, is actually a very important action that implies number three. Okay, implies the input string is as intended by the first party. Now, this is a bit similar, like, when you write a letter and then you put down your signature, all right? And so this becomes like a contract, okay, as agreed by both party. Now, let me repeat. What I'm trying to show here is that when two party go through the verification of the hash code, it is similar to us writing a letter with a signature and send it to the other side. And, the other party will also put a signature on this letter saying that I've received it. Now, as you can see, what I've just described here is actually a very simple operation. And this is exactly what the blockchain programmer are trying to achieve. All right. They have spent, like, I mean, today, this year is 2025. That means since 2009, like 26 years, oh, sorry, 16 years, they are trying to implement what I just said. But with a lot of, very huge footprint and or even some sort of a cover up, in the sense that they make it too complicated for different people to get in. Okay, now I'll just now skip to the part where we can actually look at this what do you call it, the file system, okay, with hash code that will replace the database. All right. Okay. Now, so this is actually an imaginary system, which I call the tri-species monetary system. Now, remember, when we have the blockchain, it really is about exchange between cryptocurrency and the fiat money, which is like US dollar or whatever national currency. Now, the tri-species means here we can add another one, which is bullion. Now, this is important because some of these finance, advocates believe that we need to have some sort of a system that will add the Boolean into the whole system. All right. And you see, the flexibility of this hash code, as I demonstrated just now, not only allows you to create a chain of uh, JSON string, you can also add in guarantors. And the guarantors hash code will become part of the what do you call it? Uh, Security features. Now, so I'm trying to show here is that we can actually generate hash code, right, by feeding cameras onto the feed, put the sorry the goal under the camera system and the way to generate hash code so that we can verify that such thing exists. Okay, so those are the sort of physical or mechanical details. And when you okay now so let's say this is uh the steps, right? That is Adam wishes to send some money to Donald in Thailand. Okay, so it will actually generate this well initially with this string, and this string will become I mean when you calculate the hash of this string, then we will save it as a file name. Okay, uh like so. All right. Okay, and then so you that means right with this file system where we have the user hash code ID and then also the message hash code. This is actually a complete database system, which is actually very crucial because I would say that if we want to implement, a full database in Forth, obviously, just now we have seen an example in this previous speaker. It is also, well, I mean, obviously we can go by that way, but or the other way is using this one, which is actually much more flexible. Obviously, we can try different ways. Now, what I wanted to show here is that with this series of steps, these are just the low-level operations. And these are actually the kind of steps that we need to go through, all right, for two parties, yeah, to agree with each other how much money to send. All right, so this is like A to I, all these steps here, you can go through in your own time. It basically explain these steps here. Now, why I'm trying to show you this is because we want to come through this part, all right? That is to implement this card computer, all right? Now, obviously, the whole idea here, as in like, I mean, even the blockchain or the Bitcoin people, they have their cold wallet, right? Now, their cold wallet is obviously restricted to only Bitcoin operations. So we can have our own type of cold wallet as well, all right? So, so I suppose this is where my work will tie in with all the other implementation of Forth that you guys are doing, all right? Now, okay, so this is the detail, I mean, not details, just a big sketch of what we can do in the next few years. Now, obviously, if we can get a lot of people, let's say a few hundred people to do this, then this can be done in 1 or 2 years, I suppose. But the idea here is that, okay, it is based on this idea that now this for script is the one, I mean, is the my own Forth implementation. That's the name I gave. Now we can actually translate for script into any of the third generation programming language, which is actually the one that is being used now. All right. Now, so I call this model the sandwich model because you have three layers. All right. The highest for script layer, and then the host programming language. All right. And then finally, you have the object code. Okay, so this is called the sandwich model. Now, when we have the sandwich model, okay, the first step that we should try to implement the card computer is we need to create a minimal virtual machine that has Linux, Java, I2P. All right, now the version of I2P that I'm running is written in Java, so we need to have the Java, Apache, and the PHP or whatever server there. Then the next thing that we should do is, all right, okay, we can start coding, the translating the C code into FOSScript, Java to FOSScript, and so on. All right, this is the top layer work. So at the beginning, we have zero. In the end, the objective is to replace the host language function with FOSScript. Then the middle layer, we have C library, Java library, PHP library, and so on. Now, obviously, in the beginning, it's 100%. In the end, we hope to replace it completely by the top and the bottom layer, which is why we call it a sandwich model. So at the bottom, we need the equivalent fourth library. So when we start, we have a zero of that, and in the end, we want to replace the middle layer. Now, after we do this, then what we are able to, hopefully, then we are sort of experienced enough, right, to rewrite the Linux kernel. All right. Similarly, we use the same approach. Now, obviously, if we have enough people, then number two and number three can be executed together. Now, I guess I may want to wrap up here. Just checking with Kevin, how many minutes more do I have to wrap it up? Kevin, are you there? Can anyone alert? Can you hear me? Anyone?
Yes, I
I
can.
can hear.
Right. How many more minutes do I have to wrap that up?
Stand by just a sec. 7 to 10 would be good. Does that suit you?
Okay. 7 to 10 minutes. Is that right?
Yes. Yes.
Oh, okay. Okay, that's good. Okay, so we have done this part. Okay, let's go back to uh all right, this overview to see what we have discussed so far, right? Okay, so at the beginning, okay, let's start with what I have shown you guys from the beginning, right? Okay, I started with these slides, all right, to show you fourth being used in Bitcoin. All right, that is actually how this what do you call it blockchain revolution actually started, right? Now, in a way, Forth might be the most popular programming language if you consider how many mining nodes are running, Bitcoin operation. All right. So we are not actually unpopular in that sense. But unfortunately, most of these programmer in the blockchain, they don't actually use Bitcoin directly. Now, of course, it's not their fault for not using it. But what I had tried to show in this presentation is that we can do better than Bitcoin, okay, by uh, introducing a new idea, okay, that is called, yeah, this thing, okay, triple less card computer. That is a system without domain and without kernel and without database, right? So I have proven that, we can do without database, right? So, I mean, you are welcome to download the code, from our website. As you can see in the first page of this presentation. So the next part is we need to do this domain and kernel, all right? Meaning that now the domain part is actually now uh, performed by I2P, Invisible Internet Project, and it needs a Java interpreter. So, which is why I propose this sandwich model of how we can create this. Now, in summary, in order to do this, I would say, if we have, let's say, 50 or 100 people, we may be able to do it in 1 or 2 years. And I think it's actually worth a try because if you imagine the amount of money that is involved here, and also, let's say, the uncertainty, of the world financial system in the next few years, right? Because of whoever, actually, President Trump is coming to Malaysia as we speak. I think he's already on the plane. And so anyway, I'm not sure whether he'll be happy about us talking about these kind of ideas. Now, finally, to wrap up what I want to do in the future. So there is this word called, okay, now before I go into this metanarchy, I just like to say that AI is one area that fourth programmers and also, the database-less uh, framework can actually contribute because today most of the data AI database are actually held in a centralized system. So imagine we can use the hash code as the index, right? Then basically we can actually make the data distributed or decentralized. So this is an important one. Yeah, and the first idea I haven't emphasized enough is that we need to have this system. I own my own commands, photo, videos, and source code on my own devices. And the blockchain hardware is owned by miners. All right. Now, if we can do this, let's say in 2 or 3 years, then we come to a point where we can try out metanarchy, which is the word I use for global governance structure based on decentralized transaction in the data in the metaverse. Now, in US, I believe you use this word decentralized autonomous organization. All right. So metanarchy is this DAO plus plus. And just to give you an idea, why is this essential, right? To start in a small country outside USA and China. If you are into cryptography, there is this bouncy castle libraries. They have actually registered a non-profit in Australia. Now, obviously, Wikipedia never explained why they do that, right? So we can just guess, they do that just to bypass a US law or something else. Okay, so I suppose that's all I wish to present today. And I'll take a few questions if you have. So, yeah, thank you very much. Any questions?
Are you just hashing the DNS name or the equivalent of a file name? And how would you get the initial root of the hierarchy? Like if it's DNS, there's an initial root of the. I don't know if I'm reading it right or wrong.
All right, okay, yeah, this is a good question. So what I have done usually is this. Okay, let me see if I can just open it. Okay, this is the my own GitHub repo. All right. Now, so in this GitHub, what I do is that okay, yep, this is what I do. So in order to redirect people to, let's see, is it okay? So you can use this kind of code, right? It's actually a hack, and I don't think many people know this, right? So if you actually go into GitHub and open this page, you'll be able to redirect the uh I mean the web page to this is actually I2P Invisible Internet Project what do you call it address, right? It looks very strange. It is actually some sort of hash code as well. Uh, I try to maybe answer one part of your question. I maybe I haven't answered everything. Can you maybe just refresh me any other part that you wish me to explain?
I guess I was wondering if you like just hashing the file names, and then how do you get the initial, because in DNS you have to get the initial root so you can find like where everybody else is. And I guess that, because it's centralized, right? It's still like kind of centralized, and then it's a question of how do you hash the DNS or do you hash the file names or both so you can locate what you're looking for? I guess that was my, so you can
Yeah,
locate the
I
file.
understand your question is just that it's actually a very complicated situation. You know how to bootstrap this whole thing. I mean, you can or could you maybe just send me a message in the chat area, then I can discuss the in detail with you because this is actually a non-trivial problem and it's actually a very interesting problem to discuss further. Thank you.
Thank you. I'll send you my email.
Okay. Any other question, please?
Paul, are you raising your hand there or just gesturing?
Yeah, I can't see. Just speak up, please, if you have questions.
Okay. I think it's appropriate to move on now.
So
If
shall I stop sharing, right?
last call, yes, stop sharing now. Last call for questions. Okay. I would just like to say that last month I offered for some eager beaver this dongle with the IntelliSys processor on it. And if somebody wants that, somebody spoke up and said, I want it, but I was too lazy to go back into the YouTube video and resurrect that information. And I didn't see an email. So if you're still out there and you still want it, or if any of the rest of you want it, drop me a line. It should say IntelliSys, IntelliSys, all one word, in the subject line, please. Porther@comcast.net is my email address. So our esteemed colleague Sam wanted to know in the chat or the DMs what the expected duration was. We're going to skip the haiku till fourth day. Thank you, Brad. So Sam, you've got till 11:30-ish, and by ish I mean around there.